So we are on practice quiz part 2, second video, video 2, whatever you want to call it. Let's jump right in. So on this question here, we need to split up this cube root to each of these terms. We have a negative 64, an a to the 6th, a b to the 9th, a c to the 4th. Let's put a cube root on the negative 64, cube root on the a to the 6th, cube root on the b to the 9th, and so on and so on. So I'm going to make some space here for this problem. So once you split up that root, then you could recognize that a third root is really the power of 1/3, and that's how you're going to be dealing with these later three problems. But with this first one, it's a pure number. The cube root of what number, or the cube root of negative 64, in other words, what number times itself 3 times will give you a negative 64 as an answer. See, most of the time when we have square roots, that negative comes out as an imaginary. That'd be a mistake right here, because you could actually find a number that you multiply with itself 3 times that'll give you negative 64. So what is that number? It's actually negative 4. Again, negative 4 times negative 4 is positive 16. Positive 16 times negative 4 will get you back to that negative 64. So it's not 4i, it's actually negative 4. Now this next one, you want to think a cube root is really the power of 1/3. So we want this inside power to be divisible by 3, because multiplying by 1/3 is really like dividing by 3. So once again, the power of 1/3 is the same thing as a cube root. And we do have an a to the 6th on the inside. And of course, a power to a power we multiply. 6 times 1/3 is like dividing by 3. So 6 divided by 3 is 2. So there's your answer, a squared. So we have a negative 4, we have an a squared. What about the rest of them? Right here we have the power of 1/3 as well, instead of the third root. And we do have a b to the 9th on the inside, b to the 9th. And of course, a power to a power we multiply. 9 times 1/3 is kind of like dividing by 3. So we love that we have a number divisible by 3. So 9 times 1/3, that's like saying 9 divided by 3. That'll be b to the 3rd power. So again, we want a power that's divisible by 3 because we have a third root. Right here, the 4 is not divisible by 3. So we want to rewrite it with multiplication to get something that's divisible by 3. So I'm going to rewrite c to the 4th as c to the 3rd times 1 more c. And of course, I'm going to split the third root on each of those. And this first one's really easy. That just gives you a regular c. And the other one cannot be done. It just comes down the cube root of another c. You don't have to put c to the 1. And ladies and gentlemen, this is your answer. Negative 4, a to the 2nd, b to the 3rd, c, cube root of c, which is right here. So this is the correct answer right there. Question 13. They want us to select all the true statements given this graph. Of course, you should zoom in on it to get a better visual. We might zoom in on it in a bit, but right now let's just start reading. The a value must be negative 2. Actually, let's zoom in. So when we're looking at this graph, look at your beginning point. Obviously, if it's going up, the a value would be positive, but it is going down, so that means that it is negative. And it's saying that the a value is negative 2. Is that true or false? Well, how many levels, how many units does it actually go down before it gets to the next nice coordinate? Does it go down 2 units to get to the next nice coordinate? No, it actually goes down 1, 2, 3 units to get to the next nice coordinate. This must mean that the a value is negative 3. The a value is negative 3. Again, because it went down 1 unit, 2 units, 3 units before going over to this next nice point. So that means that the a value is negative 3. This is what we call first of all, it's a reflection from the original parent graph, and then it gets vertically stretched by 3. Obviously, it gets stretched. It's not, anyway, let's just go back to the true and false. So obviously, the a value is not negative 2, it's negative 3. So this first statement right here is false. So that's why it's a red dot right there. Moving on, the h value must be negative 2. Well, what is this beginning point? That is your most important point, the hk. So from the origin, it's negative 1, negative 2, 1, 2, 3, 4, 5, 6. So it's negative 2, positive 6. That's your hk. So your h is negative 2, your k is positive 6. So again, the h value must be positive 2. That's incorrect. It's supposed to be negative 2. So this is obviously a false statement also. That's why we have a red dot right here. The domain must be x is greater than or equal to -2. That is true, because look at your x number line. The x value of 0, does it exist? Yeah, it's right there. -1, yeah, it's right there. The x value of -2, does it exist? Yeah, it's right there. Does it exist at -2.5? No, there is no part of the graph. Or -3? No. Or -4? Of course not. So it starts existing at the x value of -2 and to the right, which means x is -2 and greater than -2. So that must mean x is greater than or equal to -2, which is a true statement. And that's why it's a green dot right there. It looks like it got vertically stretched. Absolutely, this thing got vertically stretched. Normally, if your a value were 1, it would start right here and then it would go down to here, right? But this thing got stretched. It got vertically stretched by 3. So it absolutely did get vertically stretched. That's why it's a green dot right there. And the k value must be -1. The k value is 6, so that's definitely false. Whoa, that's incorrect. This should be false. So yeah, you're gonna see that that's false on your, that was a little typo on my part, but anyways, yeah, that is false. The k value is +6, not -1. So let's move on to the next one. And I didn't get the multiple choice options, it got cut off, but this is the question. What is the square root of x to the 49th power? Okay, so a lot of students make the mistake of thinking, oh, it's x to the 7th, which is wrong. Why? Because they're not asking you for the square root of 49. They're asking you for the square root of x that happens to have 49 as an exponent. So we must remember that a square root is really the power of 1/2. So on the inside of the square root, we have the x to the 49th power. So on the inside of the parentheses, we have x to the 49th power, which means that when you multiply a power to a power, you must multiply those powers. So you really have 49 times half, okay? So what is half of 49? Well, that would be 24.5, right? So this is one way of doing it, where you get your answer x equals x to the 24 and 1/2 power. But then you would have to split it. Now this might confuse some of you because I never explained this in class, but it's an option. You could write this as x to the 24th and then the x to the 1/2. Okay. Why is that? Because when you're multiplying two terms with the same base, what do you do with the exponents? You add them. So if you said what's 24 plus half, that'd be 24.5. So it's kind of like taking that x and splitting it, putting the 24 on one of them, putting the 1/2 on the other. And here's your answer, x to the 24th, x to the half. But x to the half, if you look at your multiple choice options, it's not going to be there. So your answer will be x to the 24th square root of x. All right, that's one way of doing it. Let's talk about an alternative way of doing this. We know that this, the original, is the square root is the power of 1/2. So we want this to be divisible by 2. 49 is not divisible by 2. As you saw, we got a fraction. So it'd be nice if we could change this to something divisible by 2, which we can. We're going to change it to a x to the 48 times 1 more x. And of course now we're going to split that root to each of those. And now we could actually do the square root of x to the 48th, because the square root is the power of 1/2 and 48 is divisible by 2, giving us x to the 24th. And of course we bring down that square root of x, and here's the same exact answer as that one. It's just done a different way. So I would probably prefer to go this way, but you could actually multiply 49 times half, and that'll be 24.5 or 24.5. And of course you're going to split that x to each of them, to the 24 and to the half, and there's your answer. Just change this back to a radical. It's totally up to you. I showed you two methods. Hopefully you go with the one that's more comfortable with you. We want to simplify this square root. Any type of radical, whether it's a square root, cube root, fourth root, split the radical to each of the terms. Of course, only when there's pure multiplication between your terms like there is right here. So let's split them up. And some of us could do this in our head, but let's thoroughly show our work here. The square root of 25 is 5, okay? Now, the square root of x to the 16th, I'm showing my work. I already know that the answer is x to the 8th, but let me show my work. The square root is really the power of 1/2. And on the inside of the parentheses, we have x to the 16th. And then I have a power to a power, which I must multiply using the rules of exponents. So 16 times half is x to the 8th. Okay. And what about this square root of y to the 9th? We know that a square root is the power of 1/2. Square root's power of 1/2. So we want something divisible by 2, kind of like 16 is divisible by 2. That's why it ended up being a nice answer, x to the 8th. 9 is not divisible by 2. So it's better to rewrite it with multiplication to get something divisible by 2. So y to the 9th, I'm going to rewrite it as y to the 8th times 1 more y. And of course, I'm going to split the root on those. And right here, I'm not even going to show my work like I did over here. I could have rewritten this square root as a power of 1/2 and then a power to a power multiply, but I already know that that's going to be a power of half. So 8 times half, that's half of 8, will be 4. So what I have here is y to the 4th power. And of course, this square root of y just comes down, the square root of y. What about the square root of z? It also just comes down. So the only thing left to do is to put our answers together nice and neatly organized. We have the 5, we have an x to the 8th, we have a y to the 4th, and then we have the square root, and let's put the y and the z together inside that root. Once again, I took the 5, the x to the 8th, the y to the 4th, and the y and z, and just put them in there. There's my answer, 5, x to the 8th, y to the 4th, square root of y, z. As you could see, none of these are your answer. So that's why this is the only one that has a green dot. The other ones are obviously incorrect. Whoops. Anyway, let's move on. As previously mentioned, whenever you have any type of radical that you're trying to simplify, split that radical, of course, only if there is pure multiplication inside of that radical, which there is. So let's split that 4th root to each one of those terms. So I've split up the radical, the 4th root, to each of the terms. Now I need to think what number times itself 4 times will give me 81. If I think 2 times 2 times 2 times 2, that won't cut it. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 would be your answer right here for this first one. That's a 3. Let's also remember that when we have a 4th root, that's really the 1/4 power, which means I would like this to be divisible by 4. Is 8 divisible by 4? Yes, it is. So I'm ready to rock and roll. I already know that my answer is going to be 8 divided by 4, which is 2x to the 2nd power. So I will have 3x to the 2nd power. But just for those of you that are still learning this, let me explain why it becomes x to the 2nd power. Because the 4th root is the power of 1/4. And on the inside, you have x to the 8th. And of course, a power to a power you multiply. And 8 times 1/4 is 2. Giving you x squared as an answer right there for this middle radical of the 3. Last but not least, again, the 1/4 power, the 4th root is a 1/4 power, and you have a y to the 16th right in there, and of course a power to a power you multiply. 16 times 4, it's like saying 16 times 1/4, it's like saying 16 divided by 4, which is y to the 4th. So what's our answer? There's no more radicals. Everything worked out beautifully. 3x squared y to the 4th, which is right here. That's why that one's correct. The other ones are not. Moving on. Number 17, the multiple choice options got cut off, but we're going to show our work anyway. What we need to remember is that we do not want to leave a radical in the denominator. And when it's a binomial like this, when you have a regular nice number and a radical, especially if it's a square root, you're going to have to multiply by its conjugate. Okay, so we're going to multiply this entire fraction by the conjugate of that denominator, which would be 2 plus square root of x. And what you do to the bottom, 2 plus square root of x, you must do to the top. So we have a lot of work to do. Let's begin with the bottom, which should work out to be a nice answer without square roots. So 2 times 2 is 4. 2 times square root of x is positive 2 square root of x. But when you go negative square root of x times positive 2, that'll give you a negative 2 on the outside square root of x. When you go negative square root of x times positive square root of x, a negative times a positive is a negative. And let's think, what is the square root of x times the square root of x. If you did that on the side, we already know that the answer is going to be negative, but if you did this on the side, square root of x times square root of x, that's really the square root of x times itself 2 times, and we know that the square root and the square undo themselves, giving you just x. So right here we have just a nice beautiful x. And what about the middle term, the positive 2 square root of x and the negative 2 square root of x? Those obviously eliminate. So in the denominator, we really only have 4 minus x. That's the denominator. Okay. I'm going to erase. No. I'm just going to put this in a little cloud because that was the work that we did, multiplying the square root of x times square root of x. Anyway, this is the denominator. Now let's go for the numerator. The numerator, we're going to multiply 3 times 2, that's 6. 3 times square root of x is positive 3 square root of x. Positive square root of x times 2 is positive 2 square root of x. And positive square root of x times positive square root of x is going to be a positive. And once again, the square root of x times square root of x will just be x, right? Square root of x times square root of x is really the square root of x times itself 2 times. The square and the square root eliminate themselves, leaving you just x. What could you combine on this numerator? The positive 3 square root of x and the positive 2 square root of x. That'll be a positive 5 square root of x. So we actually have this 6 out here in our answer. And then we have the 5 square root of x, positive 5 square root of x. And then last but not least, we have this plus x, plus x. And believe it or not, ladies and gentlemen, this is your answer. This fraction, 6 plus 5 square root of x plus x on the outside over 4 minus x. That is your answer for this question. So please make sure you find that on the multiple choice options. And yeah, it is true that this could have been switched with the negative x first and the positive 4 second. But I believe this is how it's going to be set up on the multiple choice. So on this next question, we have a fraction with a radical in the denominator, and we've learned that we don't want to leave radicals in the denominator. Now, to make this a little more clear to us, we might want to think of this as a rational exponent instead of a radical. And of course, we need to remember that whenever you have any base to whatever power over root, it could be rewritten as that root to that base with that power. Okay? So when you have something to a power that's a fraction, that could be rewritten as a root, right? And likewise, you could take your root that has a power on the base, and you could rewrite it as a rational exponent. So you could work both ways. Now, why am I going over that truth? Because right here, it's easier to think of this as a rational exponent. It's going to be x to the power of a certain fraction, and you're going to have a power over root. The powers to the root is 3. So in the denominator, I'm going to rewrite this fraction as x to the 2/3 power. Okay? Power over root. Power over root. Now, I want to get rid of this 2/3. I want to make it a whole x. Okay? So I know that if I multiply both top and bottom by x to the, what do I need to do to make this 2/3 to become one whole? Of course, when you're multiplying, you really add those exponents. So 2/3 plus what will give us 3/3. 2/3 plus 1/3 will give us 3/3. So we're going to multiply both top and bottom by x to the 1/3 power. And of course, when we do multiply x to the 2/3 times x to the 1/3, we're really just adding the 2/3 plus 1/3, giving us 3/3, giving us on the bottom, I'm going to put it over here at the bottom, just a nice beautiful x. Okay. Now what about up on top? We have the 5 times 1/3 x, and if you look at your multiple choice options, they are all in the form of radicals. So it's simply 5 times the 3rd root of x. So we're going to put 5 times the 3rd root of x. And that is obviously this answer right here. And none of the other ones are correct. By the way, you might have to scroll to see the complete option on your answer, or click on the actual question to see the whole thing. I think some of them might have gotten cut off, so be careful with that. Let's move on. Simplify, then rewrite in radical form. Okay, well, it's pretty easy. When you have a power to a power, what do? You simply multiply, right? So 2 times 5 is 10, 3 times 9 is 27, so you really have 10. No, I'm sorry. We really have x to the power of 10 over 27. 10 over 27. Now, the question is, could I reduce this fraction? I cannot. If I could, please reduce, all right? But since you can't do anything with this fraction, well, let's change it back to radical format, okay? So it's the 27th root over, of x to the 10th power. Remember, the numerator is the power, the bottom is the root. So you're just going to rewrite it. The 27 goes right here. The base x goes inside. And the power of 10 goes right there. So it's the 27th root of x to the 10th, which is this question right there. The other ones are obviously wrong. So there you go. Let's move on to question number 20. So this does require knowledge on rules of exponents. Anytime you have a negative exponent, you must grab it, move it to the other side. So obviously there is no other side because it's not a fraction. Well, technically it is a fraction, but you got to make it look like a fraction. There's nothing. It's over 1, so there's technically not anything down there. But we're going to move the whole thing down underneath, right? So there's going to be nothing left up on top. So you put a 1 up on top, and now you have an x to the positive 2/5 on the bottom. Now, once again, this is x squared and a 5th root, right? It's a 5th root of x squared. And you don't want any type of root in the denominator. You don't want rational exponents in the denominator. You want a nice whole x in the bottom. So what must I do? I must multiply both top and bottom by x to the, again, remember when you're multiplying with the same base, what do? You add the exponents. So in order to make this 2/5 become one whole, you'd have to go 2/5 plus something else to make it 5/5, right? Because 5/5 is one whole. So 2/5 plus how much more to get to 5/5? Obviously 3/5. So you're going to be multiplying both top and bottom by x to the 3/5 power. On the bottom, when you multiply 2/5 times 3/5, yeah, you're going to get x to the one whole. You don't need to put the 1, right? And on the top, what do you end up with? You end up with 1 times x to the 3/5. That's simply x to the 3/5. X to the 3/5. Now, of course, all of your answers are written in radical format. So keep in mind that it is power over root, right? A rational exponent is always power over root. So up on top, we have the 5th root of x to the 3rd power. And of course it is all over x. And again, you might have to scroll to see that 5. That's the only one that has a 5th root. It is x to the 3rd over x. It got kind of cut off. You might have to scroll on your answer to see the whole thing. I apologize. But that is the answer right there. And obviously these are not marked. So yeah, my bad. So yes, this is the correct answer right here. X, the 5th root of x to the 3rd over x. The 5th root of x to the 3rd over x. So here's another example where it got cut off. So you're going to have to scroll or click on the question so you could actually see the whole thing. So let me show you the whole thing. And we have a fraction that has the same base with rational exponents, okay? So we're going to use some rules of exponents to simplify this thing. What happens when you move something from one side to the other? Obviously, the sign changes. Most of the time, we deal with negative exponents. Like if this were a negative 7/9, we would take it, move it down to the bottom, and it would become positive 7/9. But what we're going to do here is I'm going to forcefully move this one up. Okay, I want to take this x to the 2/9 power and move it up. So it's going to be with multiplication right next to the x to the 7/9. It's going to be times x to the negative 2/9. Okay, it was positive. I moved it up. Now it's negative. So what do I have here? I have x to the something times x to the something. Now what do you do when you're multiplying two items with the same base? You simply combine the exponents. You normally add them, right? But we're going to combine adding, same thing. Combining, adding is the same thing. 7/9 plus -2/9. We have a common denominator, so that's pretty easy. 7 take away 2 is 5. Of course, over that common denominator, 9. So you have x to the 5/9 power. Okay. There is nothing left on the bottom. It's no longer a fraction. This is your answer. All of your multiple choice answers are in radical form. So let's again remember that it's power over root. Okay. So we have the root symbol that is a 9th root of x to the 5th power. X to the 5th power. And that is this answer right here. The 9th root of x to the 5th power. Let's move on. Well, as you can see, there's some technical issues here. Hopefully this does not happen on your test. If so, come talk to me during the test so I could tell you what options are there. Maybe you're able to scroll and see the whole thing there. But anyways, yep, this is definitely the most entertaining question with rational exponents. We're going to begin by looking at the denominator. You have 4 times x to the 1/2 times x to the -3/4. Okay, how about we begin with multiplying the x to the something times x to the something, because we know that all that does is add exponents. So what we're really dealing with is adding the positive 1/2 with the -3/4. Okay, so let me actually do that right here. Positive 1/2 plus a -3/4. Now let's go back to the 6th grade, right? To add fractions, we need a common denominator. So obviously the denominator will be 4, right? Because we already have a 4 right here. So the 4, this second fraction, the -3/4, is going to stay -3/4. But I'm going to change this 2 to become a 4. And how am I going to do that? Obviously multiply by 2, multiply by 2. So up on top, you end up with 2/4, which obviously is the same thing as 1/2, -3/4. So now that we have a common denominator of 4 right there and 4 right there, now we could actually go 2 take away 3, giving us a -1/4 as an answer. So what do I have so far? I have 4x to the -1/4 power. Okay, so let me rewrite this thing. We have x to the 3/5 over 4x to the -1/4 power. Okay, now let's use another rule of exponents. Whenever you have a negative exponent, you must grab it and move it to the other side. So what has a negative exponent? Only the x term. So I must grab that x term only, not the 4, and move it up. So it's going to become times x to the +1/4. Okay? So what do I have? Let me rewrite it so it'll stay nice and neat. We have x to the 3/5 times x to the 1/4 over 4. And of course, when we are multiplying two items with the same base, we really just add those exponents. We combine those exponents. So the simple problem becomes 3/5 plus 1/4. Once again, let's do that on the side over here. 3/5 plus 1/4. We need a common denominator. The common denominator between 5 and 4 is 20. So how do you change 5 to become 20? You multiply it by 4, so multiply that by 4 and you'll get 12 up there. You have plus, and how do you change 4 to become 20? Multiply it by 5, multiply it by 5, and that'll become a 5 up there. So what do we end up with? The final answer is, it's still 20 in the denominator, but up on top it'll be 17. Okay, now that's the final answer for the exponents. So my answer to this numerator is x to the 17th 20th power. So let me write that down. X to the 17th 20th power over 4. Now we should all know that it is power over root. So let's rewrite our final answer. The power is 17. So as we compare our answers here, the power is 17 over the root 20, all over that 4 in the denominator, So this is the answer right here. the 20th root of x to the 17th all divided by 4. The 20th root of x to the 17th all divided by 4. I hope this helps. Last question is one of the easiest. All you got to do is rewrite it as a rational exponent. And once again, we need to remember that when you have any type of root to whatever base you may have to whatever power, then that as a rational exponent will be that exact base, but you're going to have an exponent that's a fraction, and it will be a power over root. Okay? So obviously my power is 3 and my root is 7. So that would be x, the base x, to the 3/7 power, which is this one right here.